So the sixth one, read through it and try to understand what they are trying to say. When a charge is moving in a magnetic field such that the velocity of the particle is at an angle to the magnetic field, what will be the path traced by the charged particle? Derive the pitch and time period. So the first option was 90 degrees, the second option was 0 degree. Now they are asking what if it is some angle, say it can be theta 30 degree, 60 degree, can be anything. So that's the question there. So the diagram for this is very simple. So maybe I can do it here itself. So what they are saying is the magnetic field is like this, right? And the velocity of the charge, instead of going this way, let's say if it is going like this. So that means this is the magnetic field direction D, right? And this is the velocity. So this is magnetic field direction, which means this is your theta. Do you agree? So magnetic field is this way and velocity is this way, right? So that means this is going at an angle of theta. So any idea what will happen in this case? Earlier we said 90 degree means circle, 0 degree means straight without getting affected, right? So now they are asking what will happen if it is in some angle theta. What do you think will happen? Any idea? So I'll give you some clue. So any force or any vector like this, I am going to, if I resolve this into two vectors, V cos theta, this will be V sin theta. Anybody having any issues with that? If this is theta, this is adjacent. Adjacent means cos, right? Opposite is sin, right? So this is theta. If you were not thorough with the basics in your 11th standard, let's quickly do this. So this is F, this is theta, means this will be F sin theta and this will be F cos theta. Okay, just take it as a side note, not related to this question, just for your basics. Okay. Why? Because suppose if I said cos theta means this by this, so it will be F cos theta divided by F. You see, F and F will cancel and cos theta is equal to cos theta. Or if I don't know this, let's call it as X. So cos theta is equal to X divided by F. So if I want X, I can say F cos theta. Do the same thing for this one. If I take this as Y, so sin theta is equal to Y by F. So Y is equal to F sin theta. Okay. So that's simple. So whenever I have something like this, I will say this is F cos theta, this is F sin theta. Very simple, right? I'm sure you have done this many times. So coming back to this question here. So I'm resolving it into two components. One is X direction component, the other one is Y direction component, meaning it's both are perpendicular to each other. So this is V cos theta, this is V sin theta, right? Now my question to you is, this magnetic field is this way, and what can you say about the angle between this magnetic field and this V cos theta? Same, which means angle between them is 0, right? So if I consider this and this velocity alone, it's not going to cause any kind of force, which means it will just keep on going in the same direction according to this 0 concept, right? Whereas, what can you say about this V sin theta and this V? It is 90 degree. If it is 90 degree, what did we say in the previous question? It will take a circular path. So due to this, it's going to take a circular path. Due to this, it's going to take a straight path. What do you think that shape is? Parabola. And Anything else? Helical? Why helical? Repeated? Okay. The easy way to imagine this is, I know, have you played with this fireworks where they, spin it like this, right? I don't know what they call that. Any names, Yeah? You have some kind of a rope or something. No, I'm talking about the rope thing, right? Okay. Maybe I'm not talking about that one, but what I'm trying to say is, let's say you have some kind of firework which you can spin it around, right? So the fireworks is, can see the firework going out like this, right? But suppose, if you are stationary and if you are spinning it like this, you will see only a circle, right? Have you seen that? So when you are spinning it like this, you will see a circle. But suppose, imagine that you are spinning it at the same time you are running, right? So if you are running, what do you think will happen? It will go like this, because your hand is giving a circular motion, right? But with your legs you are running, right? Which means it's going to move out like this. Okay, are you able to imagine what I'm saying, right? The same thing happens here. So due to this, there will be a circular motion. Due to this, there will be a linear motion, right? So the circular motion and linear motion, when they are combined at the same time, it causes a helical motion. So it's called helix or helical motion. So take it down. So this is, let's call it as V parallel, right? And this is V perpendicular. So the V parallel is going to cause a linear motion, right? And the V perpendicular is going to cause a circular motion, circular path, a linear path. So when you combine these two things, you're not going to see a straight line, you're not going to see a circular path, you're going to see a combined effect, which is your helical motion. Okay. In fact, right, when they make springs, right, this is the principle they are using. So one machine will be just wrapping it like this, and another machine will be just pushing it this way. So one is going like this, one is moving like this. So it will be wrapping in a different path. It will not be wrapping around the same point. Spiral jump. So it's very similar to a spiral. Right? I think technically we call it as helix, but it's the same thing, spiral. Right? So is this clear? So the combined effect of V parallel and V perpendicular causes a helical motion. Okay. Any doubts here? So this is just an example. You don't have to take down this. So if you imagine that fireworks thing which I told you, it's very easy to imagine. But remember, so there is a technical term here called, so suppose if I take this point and this point, so if I take a point here and if I take a point here, right? If I take this distance, right? Any idea what that is called? Anybody? Pitch. Yeah. So you take one point, right? And then you spin it fully, right? So you take a screw, for example. So you just spin it one full rotation, right? How much distance it has gone in, that is your pitch. Okay, so this distance is called pitch. Are you able to follow what I am saying? Any difficulty? If you have difficulty, let me know. So if I go back to this spiral spring here, right? So if I take the measurement between this point and this point, right, that length is called pitch, right? So which one is causing this pitch, this movement, linear movement, this one or this one? This one, right? So this is what is causing the linear movement, okay? So what is the relationship between the, this is nothing but, pitch is nothing but length. What is the relationship between the velocity and length? Velocity is equal to distance by time. So I can say this velocity is going to cause this pitch. So if this is more, right, the pitch is going to be more. If this is smaller, the pitch is going to be smaller, right? So I can say V parallel is equal to distance by time, or if you want to take it down as velocity is equal to distance by time. So V parallel is equal to pitch by time. But this is like, one full rotation, right? So the time taken for one full rotation, what do you call that? Time period, right? Capital T. So that means instead of T, I will put T, capital T. Okay. So if you folks have trouble seeing that, let me write it here. V parallel is equal to pitch divided by capital T. Time for one full circle. You can say one full circle or one full oscillation, whatever it is. So if I want the pitch, right? So very often they will ask you some questions to find out pitch. So that means it will be V parallel into T. V parallel, what is V parallel? V parallel is equal to V cos theta. So I can simply say V cos theta. What is time period? Can you go back and check your notes? What did you find? Capital T is equal to 2 pi m by qb. So simply substitute that. So 2 pi m by qb. That's all. So that's your pitch. So they may ask you some numericals based on this. Okay. So some formulas, I don't recommend you to mug it up, but you can still try to remember some of the things. If you don't remember, then you have to start from the basics and derive it. Okay. So suppose if I don't remember the T, then I should start from mv squared by r is equal to qvb, then cancel the v and find out the v and then find out the r, then say time is equal to 2 pi r divided by v. Then if you substitute the v value, you will get the t value, right? So if you are good at remembering things, then try to remember that. If you are good at deriving things very quickly, derive it. Okay, whatever you are good at, you can do that. So pitch, here you can just take it as some distance. So pitch is nothing but you measure it in terms of length or meters. Okay, so we found some feature regarding the linear movement. Any idea what will be the feature which is very important for the circular movement? Radius, right? So, but did we talk about some formula for that? V is equal to, what is the formula? Q bar by M. So we said V is equal to Q bar by M. Okay. But that is for the entire velocity. But then in this case, the radius is caused only due to V perpendicular, right? So I am going to say V perpendicular is what is causing the circular motion. Is causing the circular motion. So we say V perpendicular is equal to Q bar by M. But V perpendicular is equal to V sin theta. So V sin theta is equal to QB R by M. So if I want the radius, I can find the radius from this. So I can say radius of the helix. R is the radius of the helix. So if I want R, I can say V sin theta M divided by QB. So take it down as radius of the helix. Any issues here? So I think if you understand these two concepts, all other things are simple mathematics. Okay, so nothing very difficult at all. So let's see if you answered that question. So it says derive the pitch and time period. So time period is same as 2 pi m QB. Okay. So we didn't derive it separately, but it's the same thing what we have done earlier. So if they ask you to derive time period, it's the same thing what you have done earlier. So T is equal to 2 pi R by T. So you will get the same thing, 2 pi R velocity. In this case, you will have to substitute V sin theta here. So it will be V sin theta here by R time. Magnetic field going this way.